So should we start? Okay. Should we start? Okay. So see what will happen, that as we discussed, that any point on link AB will be moving in an elliptical path. Okay. Okay, except the point which is in the mid of the link AB, which is called as midpoint of link AB. So if you see the path of the midpoint of the link AB, you will find that its path is a circle. Okay, midpoint of link AB will traverse or will make a circle. Okay, so if a pencil or any drawing instrument is attached at this point P, you will be able to make the ellipses. Okay, so I will show you the elliptical trammel first, its video, then you will get an idea. Okay, let me first take it out. Okay, see, uh, it is an elliptical trammel. This is the plate which is provided with slots, horizontal slot and vertical slots, and these are the sliders which are sliding there like this. It is the link AB, and we have extended it, right? We have extended it. We want, and we have attached some drawing instrument at its end. Okay, now see how it will work. Look at the motion of different links. Okay, so which kind of motion is there between this link AB and slider? स्लाइडर और लिंक ए बी में कैसे मोशन हो रहा है? दैट इज अ टर्निंग मोशन. ये जो लिंक ए बी है वो विथ रिस्पेक्ट टू स्लाइडर वो टर्न हो रही है एट दिस पॉइंट. सी इसका ओरिएंटेशन कैसे चेंज हुआ है. ओके, और you can also say it like this, that the slider is turning with respect to link AB. Okay, it is not a wrong statement. Similarly, what is the motion between slider and this slotted plate. So you will say that slider is sliding with respect to the slotted plate. It is sliding. Okay. So you got an idea, right? If you want to make a small ellipse, then you can adjust its semi-major and semi-minor axis. You can choose a different point to attach the your drawing instrument there. So I will stop it and let's come back to the analysis. Okay. So see, it is the mathematical proof that any point on link AB, okay, or its extension except the midpoint of link AB traces an ellipse. Okay. So see, we have considered a point P here. Point P is considered on link AB. It is origin. Origin is here. Okay. Now what we did, we found the x and y coordinate. X and y coordinate of point P. Okay. Say at any time the link AB is making angle theta with horizontal axis. Okay. So you can say with the help of this length, the, like length AB, length AP, length PB, okay, and the angle theta. What is the value of x? Okay, so what is the value of x? What is the x coordinate of point P? X coordinate of point P क्या होगा? As this angle is, see, so as this angle is theta here, this angle will also be theta. This angle will also be theta. So x coordinate is equal to PQ, right? X coordinate is PQ, and PQ is equal to, that is x is equal to AP cos theta. AP cos theta, right? AP cos theta, like this. Similarly, you can have an expression for y. Y is equal to PR. What is PR? PR is nothing but your PB sin theta. PB or BP sin theta, right? Then you add x square plus y square and see what you get. So I will show you its mathematical. As we discussed, x is equal to PQ. This is equal to AP cos theta. Y equal to PR or BP sin theta. So from this you will find out cos theta. Cos theta will be then x upon AP, rearranging this equation, and sin theta will be y upon BP. Then what operation is done? Squaring and adding. So इसको square किया और add किया. X square upon AP square plus y square upon BP square is equal to cos square theta plus sin square theta gives us 1. Okay. So if you remember, this is the equation x square upon AP plus y square upon BP equal to 1. It is an equation of an ellipse. Okay. Hence, the path traced by point P is an ellipse. And this AP and BP, this will be what? This will be the semi-major axis and semi-minor axis. Got it? Okay. So it is the mathematical proof of the elliptical primal. Okay, so to prove it, what we did, we first found the coordinate of point P. That what are the coordinate? What is the x coordinate with, and what is the y coordinate with respect to origin? Okay, and then we squared and added by rearranging. Okay, suppose if P is the midpoint, say if P is the midpoint of link AB, AB और का point जो P है वो mid point होगा, तो क्या होगा? At that time what will happen? Your AP, your AP will be equal to BP. Correct. AP will be equal to BP. If you put AP equal to BP here, you will get a modified equation, and that equation will be your x square plus y square, x square plus y square is equal to AP square, as AP is equal to BP. Okay, and if you remember the geometrical equations, then you will know that x square plus y square equal to something square is nothing but the equation of circle. Okay, then you can prove that if point P is the midpoint of link AB, it will trace a circle. It will trace a circle, not an ellipse. Okay, or you can say that a circle is an ellipse whose major and minor axes are equal. Okay, so it was your first inversion. It was your first inversion of the double slider crankchain. Okay, now next is your next inversion is your Scotch yoke mechanism. Okay, Scotch yoke mechanism is your second inversion of the double slider crankchain. So in this Scotch yoke mechanism, what is fixed? Link 1, that is slider, is fixed instead of slotted plate. Okay, so see what will happen. You consider again this, I will explain you. Okay, so say this slotted plate is freed. So ये जो हैच लाइन है वो हमको निकालना है वहां से, ठीक है. सपोज ये स्लॉटेड प्लेट है पूरा. नाउ इट इज नॉट फिक्स्ड, it is not connected to any stationary thing. Okay, now slider is fixed. अभी slotted plate को fix नहीं किया हमने, ठीक है, स्लाइडर को फिक्स किया है. If you fix the slider, one slider, okay, then you see link 2 का एक पॉइंट फिक्स हो गया, B point here. Okay, so now link 2 can only turn about point B. It is because one point of link 2 is pivoted at point B, right? Okay, so link 2 can turn about point B. If you will give turning motion to link 2, what kind of motion will be there between slider, okay, will be given to the slider, that is link 3, and the slotted plate, how they will move? Okay, देखो ये स्लाइडर तो फिक्स हो गया, और ये फिक्स हो गया मीन्स व्हाट, अभी इसका ओरिएंटेशन भी चेंज नहीं होगा. मीन्स ऐसा भी नहीं होगा कि जो स्लाइडर बी है वो टिल्ट हो रहा है वो पॉइंट पे, बी पॉइंट पे ऐसे टर्न हो रहा है. नो नो, स्लाइडर बी इज फिक्स्ड. Okay, now what will happen when this link 2 will turn? At that time the slider, that is the other slider link 3, it will cast, it will exert a pressure on slotted plate. Okay, it will try to turn the slotted plate. Okay, it will try to turn like this, but what will happen, this slotted plate, when it will try to turn this slotted plate, it cannot turn because of the shape of the slider. Like this, slider is fixed, slider cannot like turn like this. So as the slotted frame will not slide, will not turn, okay, but it is free to slide over the slider. So, that is link 1. Okay, so what will happen, this slotted plate will have linear motion. This slotted plate, it will have linear motion over the slider. Okay, this whole frame, this whole slotted plate will slide over the link 1 which is fixed. Okay, and this point A will be sliding in this here. Okay, so next position जो होगा वो कैसे होगा, next position it will be the position of point A. Okay, and your slotted plate will be like this. It has been it has completely slided over this surface. Okay, so this mechanism, particular mechanism, Scotch yoke mechanism, is used to convert rotary motion into sliding motion. Here rotary motion of the link 2, that is bar, is converted into the reciprocating motion of the frame, and this mechanism is used in Scotch yoke mechanism. Okay, I will show you the Scotch yoke mechanism. Okay, better we understand it with the help of a video, so that will be better. See, it is the Scotch yoke mechanism. Now you pay attention that how the rotary motion is converted into the sliding motion. Okay, so this particular link is sliding here in the slotted frame, and this link, it is complete, this plus this rod, it is nothing but your slotted frame. But you see that how the shape has changed based on the application. What is this sliding here is nothing but your slotted frame, slotted plate, but the shape has been changed. Okay, so I think you got an idea. I will now explain it with the diagram. So it is your Scotch yoke mechanism. This is your link to bar. We are calling it as bar. And link 1 is nothing but your slider which is fixed. इसको fix कर दिया. Link 2, which is a bar, has become crank because we are giving it a complete rotation. And to the crank, we have attached the slider, next slider, other slider, link 3. that slider will slide into some slot provided. Okay, so this is that frame or slotted plate. So as it will slide like this, its motion we have given to this piston with the help of this rod. So this rod will reciprocate in this cylinder like this, and this crank tube will turn. Okay, so it is called as Scotch yoke mechanism, and it is used to convert rotary motion into the reciprocating motion. Okay, one more inversion is there of the double slider crank chain. Okay, and which is obtained earlier. Okay, earlier we fixed the स्लॉटेड प्लेट, पहले स्लॉटेड प्लेट को फिक्स किया, बाद में ये एक स्लाइडर को फिक्स किया. ओके, अभी व्हाट इज रिमेनिंग? If you will fix the other slider, you will get the same motion. Okay, so in case of the double slider crank chain, only three versions are possible, three inversions are possible. Okay, so what is remaining is that now what will happen if link 2 is fixed, that is your bar. If you completely fix it and give motion to any one link, possible motion to any one link, how the other links will have the motion, you have to observe it, and then you can use that mechanism in certain applications. So we will continue in the next lecture. Okay, any doubt, if anyone having, can ask.
No, sir.
Okay, so we can leave now. I'm ending the meeting.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome.